All right, it's 3 o'clock Central Standard Time now, so we'll go ahead and get started. Welcome everyone to today's webinar. My name is Emily Kuhn and I'm on the marketing team here at Realityworks. I'm joined by Diane Ross, who is our Education Development Manager for Realityworks. Diane is going to be presenting today. She is based in Charlotte, North Carolina, and she spends most of her time in schools throughout the area, demonstrating and helping educators and administrators implement our hands-on learning aids and resources to engage their students. Before we get started with Diane's presentation today, I just wanted to cover a few brief housekeeping items. First of all, today's presentation is being recorded, and everyone who is attending today's webinar will receive via email following the presentation, both a link to the recording and a certificate of completion following today's presentation. I do also want to let everyone know that we would love to hear from you. Any questions or concerns you have that crop up during the presentation today. We will have a dedicated Q&A session at the end of the presentation today. So feel free to type your questions using that Q&A button on your screen or the chat window anytime, but we will be answering all questions at the end of the presentation today. With that, I will go ahead and turn it over to Diane Ross.
Thank you. Can you hear me?
We can, yes.
Oh, great. I was worried. Sorry about that. I know it's a bad way to start. Yes, my name is Diane Ross. I am the Education Development Manager here at Realityworks. And today I want to talk a little bit about creating student engagement through experiential learning tools. I know you've probably heard a lot about experiential learning as you all are educators. A little bit about Realityworks. Give me a second. A little slow today. So what is Realityworks? We seek to improve the human condition around the globe and help educators show the probable outcomes of behaviors and choices. Our simulation technology has been around the world for 20 years since the creation of the RealCare Infant Simulator to improve and enhance social, emotional, and physical health and technology, where our CEO, Tim Betcher, is with the Association for Career and Technical Education Board. He's also chair of Industry Workforce Needs Coalition. We are, as Realityworks, you probably see us at 100+ education trade shows during the year, and we focus on hardware, software, learning aids, and curriculum development. And what I want to talk about today is what is experiential learning, how it affects learning, especially in the realm of welding education and training. And then we're going to talk a little bit also today about electrical wiring. You may know us, if you don't, from Realityworks, from seeing the RealCare babies walking around your schools. Our products are developed with hands-on learning in mind, from our RealCare baby to our new welding and ag programs. We help teachers create lasting educational and experiential learning experiences. We have a thoughtful portfolio of products aimed at high demand, high skill, high wage careers. That's something I'm sure that is burned into your brains these days, is that high skill, high demand, high wage careers to prepare students for these careers. So experiential learning, what is it? It's learning through reflection and doing. And you may think, well, that's exactly what we do in welding. They learn about it in the classroom, and then they take that learning into the welding booth. But what experiential learning does is it explores the gaps between those two. It offers students assignments and activities based on real-life situations or primary research that engage them in reflective, data-driven problem solving. So this might be what your welding classroom looks like. You see the students in the back really not paying attention and not really seeing or engaged in what the student in the front's doing. Now the student's wearing a helmet, has a stick, possibly learning angles from the teacher, so the teacher's up there teaching them what these different things are, and it may be fine. And then from there, this student will walk into your welding booth. So that may look like what your welding shop looks like. It may be larger, it may be smaller. But what if we go from this into here, but we add a few steps in between? So what if we better prepare students for the booth? What if we allow them to work on work angle, travel angle, their technique before they pick up a real gun and just start welding? That's why we have our Guide-Weld VR. Research shows that a student who starts out in simulation learns faster and becomes a better welder overall. And then once they've got that technique down and it's refined, we send the student into your welding booth with your machines, but this time they have the same type guides they had in the simulation in their real welding helmet right there in the booth. Teachers tell us that students using Guide-Weld Live produce much better welds when the guides come off. They're building muscle memory. They're learning what these angles and how the speed and distance and all kinds of things that they need to learn. These are the gaps in between. What about assessment of their own welds? Students can take the weld from the booth and compare it to the weld defects kit to self-assess. Plus, we offer flashcards that show and explain to students the causes of a weld defect and how to avoid the defect in the future. Then, for real-world experience, students can take their weld and complete a bend test and then qualify their weld. Sometimes your teacher may not or may be a certified quality welder, but our curriculum will show them how to complete that bend test and to qualify the student's weld. This is something they will need to do as they go out in the world and they get jobs and careers. This is a diagram of a classroom that might be, it's kind of your typical setup, but this is the enhancement part. So on the right-hand side, you might see the welding simulation lab, Guide-Weld VR simulation. In this one, you see 10 virtual simulators, or Guide-Weld VR. You see the teacher standing in front of the class, and one of the VR units could be hooked up to their smart board or their projector. In this simulation, you might have, you could have 20 students in your class. You'd have 2 on each one of the simulators working together in the classroom learning. The teacher can also demonstrate welding technique on the overhead projector and do it in ways that you probably can't see once you go into the booth. Then the students would walk over to the far left there to the live welding booths that are your welding booths with Guide-Weld Live, put on the helmet and see the same types of guides that they just saw in the simulation. And from there, they may go to the visual weld inspection area and take that product that they just produced and compare it, do their own self-analysis, their critical learning skills right there in the shop. And from there, they can do a bend test too, the destructive weld testing, which helps students practice for qualification, better prepare them for becoming certified welders. It indicates the true quality of the weld and validates the student's ability to follow proper practices and procedures, something we all strive for. So we're focusing on skill building. This could be typically how a teacher demonstrates to a group of students a particular way to weld, where the students are standing probably 3 to 4 feet back from the teacher as the teacher demonstrates the weld. The students have on a helmet, of course, and all their PPE equipment, standing back while the teacher demonstrates. So what do you think that they're actually seeing when it comes to angles, work angle, travel angle, distance? It's difficult. So we want to take one step back and focus on skill building. Let's look at what these things are. What is work angle? What is travel angle? What's plate to nozzle distance? What's speed? How fast should I be going? How do I know that kind of thing? Students always want to know why. Why am I learning this? Math, angles, English. And a lot of teachers come to us and say, this is what we have to teach first. We have to teach them remedial math. They don't understand what a 45-degree angle is, what a 90-degree angle is. we have these things we have to do in the classroom. And that's all great, but then how does that translate to the booth? So what you could do is as in the earlier demonstration, we saw the picture there of the teacher up in front of the smartboard. You can project the WELDVR to your smartboard to demonstrate what these actual angles would look like in the real world. So use the virtual weld gun to demonstrate these angles. On this one, you can see the angles in practice. They look like lines on the board. Math turns into something tangible here. So you see there in A, which is in the middle, that is indicating speed. So if you look right to the left at that little icon right there on the left-hand side, and it says 8 inches per minute speed, how would a student know what 8 inches per minute would look or feel like? In this simulation, as the student goes across, they know that they're supposed to be going 8 inches per minute, but the guides tell them there in figure A to speed up, which is the green plus, to slow down, which is the red minus, or equal means they're going the proper speed. Up in the left-hand corner there, you see work angle. That's section C. It has like a little C there. And it will tell them exactly what angle they're supposed to be in. So in the bottom there, you see their WPS says they're supposed to be at 90-degree work angle. So the student knows from the guides, it tells them to move up, move down, get into proper position. Over in the right-hand corner, you see B. That's the travel angle. It's telling you to straighten up. The travel angle on this WPS, as it indicates there in the left-hand corner, 10% travel angle. So the student knows exactly what position to be put in. And there's a 1/2 inch nozzle to plate distance, which is figure D. See how it's red? That means that they're out too far. They have to push in. It'll turn green when it's right. This is a novice weld, this one. So in Guide WELDVR, it goes from novice to intermediate to expert. It becomes more difficult, and that line of E there becomes more narrow. Guide WELDVR has unlimited student licenses, and there are no yearly fees. So this is a great way for students to practice as many times as they want to build skill. Plus, students love immediate feedback. They want the answer. Notice how in this figure, both in the stick process and the MIG process, those are the two processes that the virtual does as well as the live, it turns golden. So golden means that all of those different work angle, travel angle, speed, distance, everything is in the proper alignment, so the student knows that they're in proper form. It allows them, again, to build that important muscle memory. So experiential learning goes from concept to authentic, facilitate, research-based. When we talk about authentic, we want to talk about real-world problems, authentic situations. So is it like the real thing? Yes, you got to do the proper angles and speed, distance. Facilitate, where the instructor directs and facilitates rather than just standing there and demonstrates. He directs or she and facilitates the learning. And experiential learning is research-based, as early or as late as 2010 here. Here's an overview of the curriculum. Our welding curriculum is mapped to American welding standards. I know a lot of you may use something like NCCER or something else. Those are also mapped to American welding standards, AWS. So we go from career exploration to qualifying a bend test weld. So in welding career exploration, they'll look at what are the particular things that they need to become a welder. How do I get employed, building great employability skills, to virtual, to electrical wiring even. A lot of schools like to inject this electrical to have a basic understanding of how electric works through electrical wiring. Guide Weld Live, Weld Defects Kit, bend testing, it's a total of 132 hours. So simulation allows for skill building to comprehensively understand technique before sparks. It's a 30-hour curriculum. Go into electrical, learning real-world electrical wiring in a safe environment, can self-assess, saving the teacher time. It runs on batteries. You don't have to worry about anybody getting shocked. And also it's self-directed. I don't know what that is.
Diane, we're doing a little fancy screen share here because I'm in Wisconsin and Diane is joining us from Charlotte, North Carolina. So I'm going to see if this is on my computer. Here you go,
There you
Diane. It's
go.
all
Thank
yours.
you. Thank you so much.
Sorry about that.
Yep. So back to welding, go to the welding booth with Guide Weld Live, advance from simulation to live welding, but the student sees the same guides in their helmet to take that muscle memory into the real world. Weld defects, student produces a weld and self-assesses the weld defects kit. That's a 10-hour curriculum. And then right into quality testing, the bend tester. I know that some states have actually incorporated this into their welding curriculum because one of the things we'll get into here in a minute is looking at welding as a career rather than just getting a job. Once the student completes each one of these, they'll get a certificate of achievement that's given out by the teacher. The teacher could actually print on the back the standards, the AWS standards that have been achieved over the period of time, and they could take this into the world to perhaps go to a school or, further their education, even perhaps get a job or internship, some kind of thing like that. So our whole theory of welding is that of scaffolding. We want to go from skill introduction to skill mastery, not just from here's how you do it to go do it, but we really want them to build these skills, basic techniques like angles through simulation, real practice using Guide Weld Live, critical thinking skills, taking that product that they produce and actually look at whether it has a defect, what causes those defects and how to avoid them in the future. And then in the real world context of looking at a bend test and actually performing that bend test. The assessment part of this comes within the VR. This is what it would look like. So students are given a score. What do you think happens when students get scores? They become competitive with each other. And the only way to actually get a better score, if you want to think of it like in the gaming world, in this instance, they can get better at this welding game, but the only way to do that is to improve their skill. So it tracks work angle, travel angle, plate distance, speed, and straightness. Overall score is given as a percentage, and it graphs the student progress. So you can see in this one, it goes across, it says that work angle was supposed to be 45 degrees, and they were in this one for 100% of the time. You see the grayed out area, and you'll notice if you look above there that this was a novice weld, and as these welds become more intense, such as intermediate to expert, that gray area becomes more narrow, so it becomes more difficult for the student. They have to become better at welding as they progress. Travel angle was supposed to be 10%. They did that well, but when you skip down and you look at speed, how inconsistent that is and what kind of a weld would that produce. Also, you can see over there that the score was 87%. Below that is a video. You can actually play that video back and look at your weld. You can even turn the video so that you can see the weld from the root, which is something you would not be able to see in the booth. And a lot of teachers can have used this on their overhead projector to show students these things, to indicate root penetration, things like that. Also, weld progress. So students can practice unlimited on each one of these WPS, and then they'll take a test, and that will graph their practices versus their tests. So it creates competition by producing a score, and students will try to get a better score each time. This is a look at what are the Guide Weld Live products. So you go from virtual into the booth. So they're taking that, and you want to see the guide. So this is connected to your welding machine. This is your welding gun. This is the helmet that's auto darkening. So whenever we start the weld, he's actually doing a MIG weld here. And then you get inside the helmet. So what is the student seeing? They're focused on the puddle, but there you can see the little indicators on the side for travel angle, work angle. And notice how they gray out, they kind of disappear in the student's periphery. So while they're going across welding, they're actually getting this guidance. So again, to support that muscle memory for welding. So what do teachers say? George Carr is a welding instructor that has embraced this kind of technology from the start. And he says, after using GuideWeld Live, students were providing me with feedback first, which was great. In a real world situation, your boss is going to ask you why it's this way or that. So this tool helps in that sense too. So his students are coming back and giving him feedback. So experiential learning that allows students to build skill in your welding program, from career exploration all the way into electrical wiring, bend testing, pushes them out into the world ready to confront their career. I've worked with Dr. David Barber here in North Carolina, Department of Public Instruction, and one of the things he said that stood out to me was we want to prepare students for careers, not just jobs. We can't be happy with just them getting a job. We want them to keep going, to have a fruitful life and have a great career. And that brings us back to, what does your welding program look like? Is it comprehensive? Do you go from the classroom into the booth and hope that your students develop skill and become skilled welders? Or do you give them the tools to help build that skill as they go along? From welding simulation, in the classroom learning, you can use this technology on your overhead board or your smart board, move your students into your welding booths with the guides. From there, go to the visual inspection area to assess their weld, and then go right into bend testing as well to qualify that weld for their career. Our solutions are priced for schools. We have customized bundle packages available to enhance or help you start your welding program. It's not just one size fits all. We want to work with you to help you. We can develop something. The curriculum is designed for skill building and experiential learning to develop skill faster and make it more meaningful to those students. So experiential learning, our GuideWeld products are designed to build skill faster inside your welding program. And we also offer some other things like these portable workstations that you won't find anywhere else. It depends on kind of what your situation is there at your schools. So now I got a little bit of time left. We got about 7 minutes or so. And I just want to kind of open it up to you all. Does anybody have any questions?
All right, Diane, thanks. I'm going to go ahead and take back your mouse control here.
Okay.
Yes, at this point, all our attendees, Diane's available to answer any questions. She's got extensive experience in this field, so she's a great person to ask if whatever you're wondering about any of the information that she just shared. You've got 2 buttons on your screen. One says questions and answers, and one says chat. You can use either to ask a question. In the meantime, it looks like, Diane, this is a question about internet that you probably get a lot?
I do. I get this question a lot. Do I need the internet? And the answer is no, you don't. You don't need the internet for it to work. You need the internet to download the software the first time. But a lot of teachers are in areas where the internet may not be real strong or they have wireless, but you can connect this to a computer and you don't need the internet to do it all. You can set it up in a couple of ways too. One of the ways I like is, especially if you have multiple units in your school, you can put the database right on your school computer system, like your own server, and then you would only enter the student names once, and then any machine that the students go to, they can log in, they have their own login and everything, and they can use whichever machine they want each day. They don't have to go back to the same one.
Fabulous. That is great information to hear. And it looks like, I'm not actually seeing any questions or any information in our chat, which is fine. Hey, if Diane answered all of your questions, that's great. We will go ahead and just in case anyone, oh, you know what? Sorry about this, Diane. I didn't realize you had another question up here. This looks like it's also a good one if you want to take a minute to answer that one as well.
Yep. So what kind of computer do I need for VR? So a lot of times when you have these high-end games, you've got to have a really high-end video card and all that kind of stuff. And ours is set up so that you do not have to have the high-end video card, but we do have the specs for computers, and they are really not all that robust. If your computer is probably anywhere between 3 and 0 years old, then you're probably in good shape. If it's older than that, we'll send you the information for the video card just to make sure that you have all the updates and everything you need for that as well. So you don't have to have that high-end robust computer to run it. Thanks, Diane.
How about this? How much of each do I need? That's another great question.
And that is something that we will work with you on, because there's a lot of considerations, including cost, and but we can put together a plan so that we can look at how many students you have, how long are you spending on each process, and all kinds of things like that, and we'll actually work to customize a plan just for you. And it may be over a few years. It may be, you may be writing a grant. So get with us and we can put something together for you to, to consider.
All right. Well, thanks, Diane. I still don't see any questions from any of our attendees. So Diane, I appreciate you sharing some extra information there at the end. If any of you have any questions after this webinar is concluded, please feel free to reach out to Diane. She's happy to answer any additional questions. Otherwise, everyone who's with us today, thanks for taking the time to join. Keep an eye on your email because we will be sending you both a link to the recording once it's posted in a few hours here, as well as a certificate of completion for taking the time to attend today's presentation. And with that, we'll go ahead and conclude everything. So thanks again for joining us today.
Thank you.